Welcome to everybody, and thank you for your participation to our webinar on low-cost technologies for wastewater and sludge treatment. My name is Sergio Galletta, training coordinator for Hydroaid, Water for Development Management Institute. And today I'm the moderator of this webinar, jointly with my colleagues from WaterLinks. Just some information to better participate to our webinar. All participants' microphones are muted. The chat box is available to send questions to the speaker. The webinar will be recorded and available on Workplace and WaterLinks website. Okay, now we will see the program of today. We have 3 speakers from water utilities and university, one from Politecnico, one from Smart Water Utility, Italian Water Utility, and one from OWSSB from Indian Water Utility. I think that I can give the floor to Dr. Quazzo for the welcome of the webinar. Thank you.
Thank you very much, Sergio. And as I have already said in the previous seminars, the opening speeches, the welcome remarks at the beginning of our works are all the most welcome when they are short and contained. I will therefore try to minimize the time to respect this principle that I think everyone appreciates. We are proceeding along our path of exchanging experiences, and we are returning from the recent conference in Bonn, the SO-WOP conference, where we have been able to clearly perceive that there is a really great attention and expectation on the success of our collaborative projects like this one. I do think that the colleagues who were present in Bonn can confirm this strong feeling. I have to say that in our past we had the opportunity to share the consideration that even several hours of flight away, the problems associated with the management of the integrated water cycle are similar, and sometimes they are really the same. In our globalized age that allows us to share experiences more easily, we have the tool, we have the skills, and we have to exchange this point of view. The only real problem that we have to face with the implementation of this project, which I mean in themselves are feasible, effective, and easy to access, is that the ease of finding us, of exchanging ideas via a chat, via a seminar, is the everyday overload. In other words, we expect it is definitely possible to add activity to a daily reality in which we are all already busy and with already very intense working days. For example, I will not be able, unfortunately, to attend the full seminar because we are preparing our yearly assembly, which will be very shortly, and so I will have to leave for a commission. In any case, to make a long story short, we think that the reward for this effort that we are asking of the effort of all is very high, because it allows really to grow together in a relationship that is very different from the usual, and which sees a party that sells, possibly a seller of equipment or technology, and the part that buys. Our relationship, on the other hand, is among peers. And it doesn't involve any purchase, it doesn't involve any payment of good, and therefore it's not spoiled by the thought of the interest. So, having said this, this long premise, even if I promise myself to be short and concise, let's move on to today, which is dedicated to the low-cost technologies for the treatment of wastewater and the treatment of sewage sludge. The goal, as always, the exchange of experiences between OWSSB and SMAT, with the contribution of Turin Polytechnic, the Hydroaid school, and with the precious support of Waterlinks. As far as SMAT is concerned, in addition to the description of the company that my colleague Mesiano will make, we will also bring some concrete operational examples of the application of low-cost technology on plants that we are currently managing. And this is precisely to reiterate that the problems related to the management of water and the relative solutions are similar, even several hours of flight away. So I wish everybody good work, and thank you very much for your attention.
Thank you, Dr. Quazzo, for your welcome speech. And now there is a moment for the audience poll, correct? Otherwise, we can start with the introduction. Let me introduce shortly. Okay, audience poll. Okay. So please answer this question. Only a few minutes.
Yeah, let's give everyone a minute and a half to participate in this. Is it easy for you to? Why is nobody answering it?
No, it is not editable. I mean, no, you cannot do anything here. It is not interactive.
It's not interactive. I agree. It's not, but maybe just for us. What about for the participants? Also not happening?
Not happening.
No, not happening.
Okay, in which, no, there is, it's happening. So it's not editable from us because we cannot respond, but the participants can. So participants, please participate. You can. I'll give you 40 seconds more and okay, I think that's it. We're fine. I'll end the poll. Yoli, would you like to read the results?
I cannot see the results from my computer. Okay. So for the results, in terms of expectation, is the number one to know the different low-cost technologies available. And then most of our participants are coming both from private utility and government, and mostly are occupying a technical position and mostly have their own wastewater facility to operate, while also a considerable number are in the process of constructing their wastewater treatment facility. Thank you.
Excellent. Sergio, please.
Okay, thank you. And now, as I said before, introducing the speakers, let me introduce you, the Association Hydroaid, additional partner in SO-WOP project. Hydroaid is a non-profit association consisting of permanent members with the main purpose of fostering capacity development, encouraging the sharing of knowledge, and enhancing skills and competencies in the field of water resource management. The members of Hydroaid are in the bottom of the slide. They are the local water authority of Turin, ATO3, the Piedmont region, the metropolitan area of Turin, the municipality of Turin, the water utility of Curing Smart, Curing Polytechnic, and Hydrodata, a private company specialized in water resource engineering. Okay, the slide, thank you. Since 2001, Hydroaid has been an active player in the capacity development process. Hydroaid mainly implements free training courses in different modalities, on-site, e-learning, and blended learning, development cooperation project, especially in Africa, especially but not only in African countries, and educational programs for schools in Italy. The domain of the association, of course, the water resources. The network of former and current participants to Hydroaid's activities include more than 8,000 professionals worldwide in 89 countries through more than 50 projects participated by our staff since its establishment in 2001. About 86% of these professionals is from the public sector, about 11% from university and research centers, and the last 3% from private companies. Okay, next slide. There is some about water resources. There are some topics which we deal in our courses and in our activity, as is shown in this slide. Thank you very much. And now let me introduce the first speaker about overview of low-cost technologies and polytechnic experience. The first speaker is Marco Ravina. He's an assistant professor at the Department of Environmental and Infrastructural Engineering of Turin Polytechnic, Italy. He owns 7-year experience on the study of environmental engineering, including both modeling and experimental activity. His activity is mainly addressed to environmental sanitary engineering, pollutants dynamics, wastewater treatment in developing countries. He is author of more than 40 scientific publications in peer-reviewed international journals. And then I give the word to Engineer Marco Ravina. Thank you.
Thank you. Thank you, Sergio. Thank you all. And okay, so my speech of today is to give an overview on low-cost technologies for wastewater treatment in developing countries, and to show some experiences from Politecnico, mostly related with this SO-WOP project. Next slide, please. Low-cost technologies provide support to the achievement of safe fecal sludge and wastewater management. The objective of their application is to transform primary products into secondary products, and these secondary products must have lower contaminant features, or if possible, these must be valuable products. So the final goal, so we can have different kind of processes that use physical, chemical reaction, and the final goal is to minimize waste and contamination and remove pollution, and also, if possible, foster reuse of water and sludge. Next slide, please. The international research on low-cost technologies, especially what has been done by the Swiss Institute IAWAG, identify 5 functional groups. These functional groups are user interface, collection and storage, convenience, semi-centralized treatment, and reuse and disposal. By cross-linking this functional group, the best solution, the best low-cost solution for water and sludge treatment can be found. But next slide, please. Okay, and today we want to focus more on the semi-centralized system. Next, please. The treatment plants, the important steps that must be provided by treatment plants is solid liquid separation, stabilization, dewatering and drying of the solid components, and pathogen reduction. And the appropriate level of treatment must be designed for looking at to the end use and or disposal option that is selected. As you can see in this picture, there are different technologies that can be used that provide these four steps, these four stages of treatment. But also, next slide, please. The appropriate level must be designed with a look into the final use, if it is discharge or reuse of water and sludge. And with this respect, the treatment must comply with the standards and guidelines for contamination of the environment and human health. The pollution and health standards are defined depending of the end use of the discharge and vice versa. So in this, as an example, in this table, I reported the European discharge standards for phosphorus and for nitrogen, just to give an example. And next slide, please. But what it is interesting to show is that these discharge standards show a large variability depending on the countries, depending on which is the methodology to define these standards, and which is also the characteristics, the features of the environment that receive the treated wastewater. In this table, this is a review paper from 2020. It is very interesting because it shows the variability of the discharge limit. See, for example, the variability of total nitrogen that shift from 5 milligrams of total nitrogen per liter in Ireland to 70 milligrams per liter in country Jordan. So next slide, please. This is a brief overview, but what I would like to talk about today is our experience in our the supporting OWSSB in upgrading capacities in wastewater and fecal sludge management. It is abbreviated as SO-WOP project, in which we all the participants, all the mentors and mentees have selected this case study, that is the Jatni septage treatment plant. Next, please. This Jatni septage treatment plant, it is a small plant. It has a capacity of 20,000 liters per day. Here you see a brief scheme of how was the plant conceived. The black water is discharged by cesspools into a settling tank, and then the settling tank water and solid liquid and solid phases are separated. The liquid phase goes into an anaerobic baffle reactor where the organic load is removed, partially removed. Then we have a planted gravel filter, and finally a polishing pond. The solid phase is sent to sludge drying beds that use mainly the sunlight to remove water from sludge, and the the best option, the objective would be the possibility of reusing both the solid for composting and the treated water for example, for irrigation in agricultural activities. Next, please. So in last November 2022, Politecnico and SMAT, we had a field visit to Odisha State, to Bhubaneswar and to Jatni, of course. It was a very fruitful visit with a lot of technical exchange, field visits on the plants, and also training section. In this, this was the occasion to know more about these plants and to evaluate, possible possible solution. Next, please. So by resuming very brief resume of our working activities, we analyzed the Jatni septage treatment plant. We also got analysis of water and sludge quality, and we compared with this analysis with the standards currently in force. This gave us the possibility of evaluating possible improvement action, and we found three main improvements, the main kind of typology of improvements. The first one is improving low-cost measurements of water qualitative parameters. The second one is the improving in general the efficiency of removal of contaminants of the plants, with a particular focus on nitrates. And the third one is improve the water disinfection. These are specific, okay, thank you. These are specific tasks, objectives specific to this plant, but in general, we can say that these can be extended to other to similar plants of this size, and next slide, please. So if we consider this possible improvement one by one, the first one is improving laboratory analysis. This is because analyzing water quality parameters is essential to understand what's going on in the plant, basically. Understand the removal performance, and especially at different stages of the treatment process. In our specific case, our suggestion from SMAT and Polito was the purchase of a field spectrophotometer, and that is an equipment that has limited cost, that can provide fast analysis, good resolution, and good repeatability. And this equipment works by using dedicated kits that are very easy to use, and also needs limited training. So this is just a solution to improve laboratory analysis, but is the one that we found for this specific case. Next, please. Next, please, again. Thank you. So, the second kind of improvement what we detected was the removal of nitrates. So in this case, we consider that was necessary to improve the nitrification stage. So one solution could be an intervention on the process, such as a recirculation of the water from the outlet to the inlet of the treatment. Next, please. And another, next, please. Again. Okay, so we see everything together. And another step, very important step, is constructed wetlands. Constructed wetlands have high potentiality of removing all kind of pollutants. And these systems can be designed in different ways. We can have free water surface, submerged flow with horizontal flow, or submerged with vertical flow. The one we have in our case study is an horizontal flow, is submerged with horizontal flow. And maybe a possible solution could be the change to a vertical flow. So because vertical flow wetlands are more effective in nitrification. Next, please. And then also regarding this, we started an experimental activity here at Polito regarding the possible absorption of ammonium and phosphates by means of low-cost absorption media. And we are using a raw biochar. You can see a picture of the installation there. We built this absorption column in which we pump our synthetic water that has a concentration of ammonium, a known concentration of ammonium, phosphates, and COD. And we want to run some tests to see the ability of this raw biochar to absorb these contaminants. This is because we selected the raw biochar because this could be a material that can easily be found or also be produced in developing countries. We just started, so we still don't have results about this. Next, please. And finally, third possible improvement, that is maybe the most important, is disinfection. Regarding disinfection, there are different methods going on that are possible to use, but these methods have all some advantages and disadvantages. The most promising seems to be solar disinfection, the so-called SO-WOPs, because it does not require chemicals, because it just uses the ultraviolet radiation of sunlight and can be used anywhere, but it still has many limitations in the sense that it cannot guarantee a full disinfection of water, so there's still a residual risk. So with this brief overview, I finished, and I leave the floor to other speakers. Thank you for your attention.
Thank you very much, Engineer Marco. Thank you also. You are perfectly in time, and your presentation was clear and interesting. Now I would like to introduce you Nicoletta Mesiano. She is an industrial chemical and has been working at WWC.
Sorry, Sergio, before you introduce Nicoletta, I believe there's a question from Ruhaida of In the Water Consortium. What is the capacity of the septage plant is the question. To Sergio, to Marco.
Okay, I also ask confirmation to Mr. Mapatro, but it is 20,000 liters per day, right? On average.
Yes, it is 20,000 liters per day.
Thank you.
Thank you
Sorry,
very much.
Sergio. Please proceed.
No, thank you.
Thank you.
Thank you. So now the next speaker is Nicoletta Mesiano. She's an industrial chemical and has been working at WWTP, Wastewater Treatment Plant, since 1999. She managed for 4 years an analysis laboratory in Collegno, WWTP of SMAT Group. Subsequently, she has specialized in the management of WWTP and in the reuse of water in Collegno plant managed by SMAT. Collegno is a little town close to Turin. Since 2021, she has been head of the WWTP sector of the Southwest Purification Pole of the SMAT Group. Please, Nicoletta, this is your time.
Morning. Today I am speech about low-cost technology and sludge treatment and experience on SMAT. Go on, please. Who is SMAT? SMAT is a company who shares the entire public, manage the integrated water service, production, distribution of drinking water, wastewater collection, treatment, use, and restitution to the environment for the city of Turin and 288 municipalities of the metropolitan area and over 2.2 million inhabitants. So also SMAT has an activity in non-core logic and operates directly and through subsidiaries in the field of engineering, training, laboratory activity, and service consultancy by technical, administrative, and managerial in Italy or abroad. Go on, please. So SMAT is one utility for the integrated water cycle through a network of 12,842 kilometers. SMAT guarantees the distribution of an annual production of over 180 million of drinking water produced by 90 water drinking plants. SMAT drinking water plants is the first Italian chemical biological plant which used surface water. 10,150 kilometers of sewerage ensure the collection of wastewater, which is conveyed in the 412 treatment plants managed by SMAT, including Castiglione Torinese plant, the largest recovery center in Italy and one of the largest in Europe. Go on, please. What about Turin and his metropolitan area? The metropolitan area of Turin included the main city, Torino, Turin in English, and the following 31 municipalities. We are in Piedmont. Go on, please. And now I show you the plant that we show you. This is two plants in the Susa Valley. Susa Valley is a valley in the metropolitan city of Turin in Piedmont region of the northern Italy, located between the Graian Alps and in the north and the Cottian Alps in the south. It is one of the longest valley in the Italian Alps. It's extended over 50 kilometers in the east-west direction from the French border to the outskirts of Turin. The valley takes the name of the main city, which is Susa, and the Dora Riparia River, a tributary of the Po, flows through the valley. Next week. Okay, this is the first plant. This is a plant in a city, in a village named Assiere in Meana di Susa. In this picture, you can show the sewer is mixed by gray and black water, and the type of wastewater plant is a hemothank, a treatment filter. The plant design nominal potential is 120 inhabitant equivalent. The flow rate is 480 meter cube per day, and the point of discharge is River Giorgiasso. The next slide, please. Here we have the plant with some picture about it. Next slide, please. And now in this picture, we can show the inlet plant with the manual sewage screen and the gritting section. Next slide, please. Here we are the treatment filter and the how to treat water. Next slide, please. And we have gone with the slide, please. Okay. Now, please come back, please. Okay. This is the core of the treatment. The treatment filter is one of the common anaerobic or aerobic biological treatment. The advantage of this treatment is that it's very compact, and they efficiently reduce organic matter. The filter consists in a cylindric tank and is filled with a specific surface. In this plant, we use a plastic filter media, but it's possible to use a rocks gravel, for example. An specific surface provides a large area for biofilm formation. The organisms that grow in the thin biofilm of the surface of the oxidize the organic load of the wastewater to carbon dioxide and water, while generating new biomass. Go on, please. And now about a picture about the cleaning with a vacuum canal jet. We show you how we cleaning the gritting section of this plant.
webinar ache.
Really?
Go ahead, go ahead.
Go ahead, please. Go on.
No, Nicoletta, I think Christine, can you mute, please?
Yeah.
And Nicoletta, please proceed.
Okay. Here we are a table with a low analysis about this plant with the inlet and the outlet of the plant with the measure of parameters, and go on, please. After that, I show you the other one plant. The village is Saretta in the town of Meana di Susa. The type of wastewater treatment plant installed is hemothanks, and the nominal potential of the plant is 150 inhabitant equivalent, and the flow rate is maximum 60 meter cube per day. I show you that there are one sewage pipe to this plant, and this is the picture about the inlet and the outlet of the plant. The next slide, please. This is the plant. We have in the number one, I show you the sewer piping. The number two is the inlet and the bypass of the plant. After we have the manual grid and two HIMOF tank, one for the primary sedimentation, one of the secondary sedimentation. And after we have the outlet plant with discharge in the river. The next slide, please. Now I show you, go on, please. Okay, go on. Okay, go on, please. Excuse me, can you back? It was the, okay. We have the main street. I show you the sewer piping. There is the inlet plant, and after the manual grid. The next slide, please. Go on with another one, okay. And we have the primary sedimentation. The first is an IMOF tank for the primary sedimentation, and the second is another IMOF tank for the second sedimentation, and the outlet of the plant. Go on, please. And now I show, because we, to cleaning this HIMOF tank, is necessary to have more than 60 meters of pipeline from the main street to the plant. And in this picture, I show you it. Okay, go on, please. Here there are the analysis about Sorette plant, one inlet, two outlet plant. Go on, please. And now I want to speak about our experience about supporting OWSSB in upgrading capacities in wastewater and fecal sludge management. We are working in the area 2, development of low-cost technology for wastewater and sludge treatment in Jacni sector treated plant. The first phase was to analyze the baseline situation in the septage treatment plant of Jacni. The second phase was the analysis with 6 online meetings from February 2022 to September 2022. The work activity followed this phase was data collection and technical evaluation of Jacni, data collection and evaluation of water and sludge quality. After that, we went in a technical visit to Barneshvar, and here we are in the phase 3 with the proposal. Now we have 2 online meetings from October to May 2023. And research on water and sludge quality standard with the evaluation of analysis, protocol analysis, and assessment of the possible technical intervention on Jacni treatment plant in view of water and sludge quality improvement. Now, Marco Ravina called about the improving laboratory equipment. We are sending the instrument in Jacni, and another proposal is improving process efficiency in nutrient removal. Okay. Thank you for your attention.
Thank you, Dr. Coletta, for your presentation. It was interesting to know how smart use low-cost technologies, but also use very costly technologies. It depends on the context of settlements. Okay, we are in time. Some question I can read. What I think for Engineer Marco, what parameters can you test in the field spectrophotometer?
Better if Nicoletta Mesiano replies to this. She's the expert in laboratory analysis.
Okay, you can test all the parameters. The main parameters for wastewater treatment plant are nitrogen compound with ammonia, total nitrogen, phosphorus, COD, BOD, metal, and you can try to search what do you want in internet. Okay.
Okay, thank you. Thank you very much for your answer. And now let me introduce the third speaker, Engineer Prasanta Kumar Mohapatra. He's the engineer-in-chief working for Odisha Water Supply and Sewerage Board, Housing and Urban Development Department, Government of Odisha, India. He has done his graduation in civil engineering from NIT Rourkela, post-graduation in water resource engineering from IIT Kharagpur, and master's in sanitary engineering from IHE Delft, Netherlands. He has a very rich experience and is instrumental in bringing the black water security for urban Odisha. He is now responsible for the treatment of grey water in urban Odisha. Please, Engineer Mohapatra, you can start. Thank you.
Good morning and good afternoon to everybody. Next, please. So here in this today's webinar, I am going to speak on the background of the Water Operators Partnership. I will be touching upon the planning and technology of our fecal sludge treatment plants we adopted in Odisha state. I will be talking about the capacity utilization and performance of the FSTP at Jatani, which Marco was talking about. I will be talking also about the cost and the gender inclusion in the operation of our plants. Also, I will be dealing with digitalizing the fecal sludge and septic management service in Jatani plant, also in other plants of Odisha. And I will share our learning experience from this partnership. Next, please. Our SO-WOP project was approved by, it is a EU-funded project approved by UN Habitat, and the agreement was signed by SMART and UN Habitat in January 2022. And then among us, SMART, OWSSB, Waterlinks, Hydroaid, and Polytechnic of Turin, we signed our agreement in March 2022. The overall objective of this partnership for OWSSB is that we wanted to gain knowledge, exposure, and expertise so that we can improve our capacity in managing the wastewater, both black, grey, and wastewater, and also improve the operational efficiency of the fecal sludge treatment plants. So we have defined 4 work areas in this partnership: drainage modeling, low-cost technology for grey water and septic treatment, treated wastewater and sludge reuse, and solutions to improve wastewater processes. Our 2 mentors have already defined the work so far. Next, please. To give a background of my state, Odisha, it is mostly a least urbanized state. Mostly 17% people live in urban areas. And then these urban areas, we have 61 notified area NSEs where 16% of the urban people live. We have 48 municipalities where 43% people live, and we have 5 corporations. They are big areas, big cities, and 41% of the urban people they live. So total urban population is around 7 million, and our population in the state is 42 million. Next. Till 2022, OWSSB has built 13 STPs in 6 cities with a combined capacity of 375.5 million liters per day. We have built 110 FSTPs in 108 cities with a total capacity of 1.917 million liters per day. These fecal sludge treatment plants, they have an individual capacity of 10,000 liters per day up to 75,000 liters per day. And the Jatini plant is 20,000 liters per day capacity. And after the construction, we have handed over the operation and maintenance of these plants to the women and transgender Mission Shakti groups. We call them Mission Shakti groups. They are all basically women and transgender groups. Next, please. By 2023, we have achieved 112 fecal sludge treatment plants in 110 cities. On the left, you can see the drone images of few of them. The whole treatment processes, the layouts you can see in these photos. We will be constructing another 8 FSTPs so that we achieve the goal of 120 FSTPs to cover all our 115 towns and cities. Next, please. This is the actual layout of a fecal sludge treatment plant. We have the receiving chamber, we have settling thickening tank, anaerobic baffle reactor, then the planter gravel filter. So we use the wetland. We call here planter gravel filter. So PGF or wetland is used for removing pollutants, organic matters, and also some degree of nitrogen and phosphorus. And we have polishing pond where the effluent is further transformed by exposing to sunlight and air. The sludge is the thickened sludge from the thickening tank, settling tank, is pumped to a sludge drying bed where it is dried and used for landfilling nowadays. Next, please. Here we show you the capacity utilization of the Jatini plant. In the beginning, the plant utilization was less than 10%. Once we had this partnership, the visit by the mentors, and also strong interest by the urban local body, the Jatini municipality, and community mobilization, the performance of the plant has improved. Capacity utilization has also improved. The pink bar is the 50% capacity. Now we have almost reached more than 50% capacity. Now in this plant, in this design that you saw, Marco explained and you saw the layout, we are able to meet the treated effluent BOD, COD, TSS and pH standards. We are not targeting nitrogen and phosphorus removal. And since we are using the treated effluent in landscape irrigation, so we believe the nutrient would be useful in the landscape irrigation. Now we have started after this WOP program and series of training courses. We have attempted to stabilize the dry sludge by co-composting process. So we have initiated the co-composting. The pilot work has already begun, and we have till yesterday we completed 2 pilot trials, and we have commenced the 3rd trial from today. So we'll be obtaining a lot of results from the test reports. So we'll be testing the co-compost. We have already obtained the test result from the dry sludge. So once we get the result from co-compost from various batches, so we'll be able to compare the usefulness of this procedure. Next, please. Here is the performance of the plant. We try to measure these parameters which are very relevant for us in a third-party laboratory. We find here that COD, BOD we are able to manage. Of course, we didn't have lot of sample testings. We have to conduct a lot of tests. So once we receive the UV spectrophotometer, so we will be collecting the samples from all the unit processes and test the effluent parameters. But here I present the result from the raw sludge and the treated effluent at the end of the pond, polishing pond. So at the end of the pond, we see COD and BOD are more or less within the limits. And so also the ammoniacal nitrogen and TKN, if you find, we are not able to remove nitrogen. And also we are not able to remove phosphate. We are not able to meet the standards for the phosphate. So phosphate, as you saw in Marco, it is 1 milligram per liter. So still phosphate is high. Because we are using that in landscape, so we are not intending to remove the nutrients, but since as per the 2019 standards, we have to achieve nitrogen and phosphorus. So we need to improve the processes, and for that, this partnership will be very, very useful. As far as fecal coliform, we had conducted the test through a third-party laboratory, and the result shows it is below 1000. So it is within the limit. But then Marco has suggested a lot of options for reducing that. And in this case, in this plant, because of the polishing pond, water is exposed to the sunlight, so the SODIS will come into play here. So because of the ultraviolet radiation from sunlight, so we should be able to achieve the fecal coliform standards. And of course, during rainy days or cloudy days, this could be problematic. But however, in most of the time, we should be able to achieve this. And for this to be confirmed, we have to collect a lot of samples and test them to be on the safe side. Next, please. Here I present the cost of fecal sludge treatment plants in Odisha. So we have constructed, as I mentioned, 112 plants so far. So the costs are different, and we have built at several places through public procurement procedures by inviting tenders from the local bidders, national level bidders. Jatni is a 20 KLD plant, and there is a lot of variation. Even in a 20 KLD plant, you can see a lot of variation. So depending upon the location, bidders quote different rates. And the other important aspect of this slide is that if you have seen the or marked the photographs in the plant itself, it is beautifully laid out with roads, drains, boundary wall, landscape, and buildings, guard rooms, storage shed for the safe keep of the dry sludge. We have solar power, 10 kilowatt capacity solar panels on the top of roof of the buildings. We have washing platform for the vehicles. So all these ancillary components in the FSTP, they also cost significantly to the cost of the FSTP. Next, please. In the operation and maintenance of these FSTPs, because it's a nature-based treatment system, it is not complicated, doesn't have much of the mechanical equipments except small pumps, which are more or less than 1 kilowatt capacity. They have been turned over to the Mission Shakti groups, mostly women groups, for the operation and maintenance. The Jatni plant has been handed over to women group, and there is also a technical person, resource person, to operate the lab there. We have in all the plants, we have a laboratory, and the technical resource person is able to conduct the test. So we provide regular training to the resource persons. Provide training to the Mission Shakti groups, the women groups, before we turn over the plant for maintenance. And the other aspect is that we pay them by 7th of each month. So there is automatic bank transfer to the, and we also don't charge any tipping fee for the dislodging vehicles at the FSTP. And the entire O&M cost is borne by the ULBs. And to give the picture of how many people are working in these plants, you can see the table here. We have 2 sanitary workers. We have a gardener come watcher, 1 person. And the technical resource person is also the plant manager. So we pay monthly Indian rupees 60,000. So that is what we pay them. And to give you the equivalent, €1 is almost, so let's say 90 rupees. Rupees 90 is €1. It's almost something around €700 per month. Next, please.
Okay, excuse me, Engineer Mopatra. The time is finished, but you can have 2 minutes to finish. Thank you.
Yes, thank you. So I'll be finishing very quickly. Now we have started digitalizing the fecal sludge management service at the town level or the city level. So there is an online platform where all these desludging operation is registered, and that also helps us in knowing the capacity utilization of the FSTP. The information that I gave you is coming from those online platforms. We know when the request is coming and how many days, what is the date interval the service is provided, and how much money has been paid, and how much strip has been dislodged at the discharge in the FSTP. So all these informations we are able to get through this online platform. Next, please. Now, what is our experience from this partnership? We had a lot of online courses, webinars, and also focus area group discussions with our mentors. Our mentors, 2 mentors, previous speaker, they have given a elaboration of what has been done. So our engineers have been mostly benefited from these discussions. We shared a lot of information also in the shape of documents, standards for analysis, and also to gain information. During the mission also, the mentors visited Odisha last October. So we also got a lot of information, a lot of discussion with our women group. So they also appreciated the mainstreaming of gender and community partnership in our operation and maintenance of FSTPs. So that has led to the empowering of the women and transgender groups. And because our plants are all nature-based dewash technology, so this has allowed us to tweak with to also look at how do we improve the processes, what intervention we can do to improve the nutrient removal in these FSTPs. So this has also a lot to do with the technology that we adopted, and our mentors, they have appreciated the use of this technology for the given setting. We are doing now the treated effluent is reused in landscape irrigation. Now through this partnership, we have also started working how best we can use the treated water in production of concrete. So that work is also on trial. I have mentioned that we have started the piloting of dry sludge co-composting in Jatni FSTP. So all this information at the end of partnership will lead to generation of lot of information, technical information, standards, and also some publications and overall capacity building of OWSSB engineers. So these works are all in progress. Next, please. So I thank you for your kind attention. And these are some of the photos. Back, you have already seen these photos, and some photos are during the time our mentors from Italy and also Waterlinks partners, they visited from Philippines. And you can see on the top middle, you can see the ladies. They are the people engaged in the operation and maintenance of the plant. Behind them, you can see the beautiful flowers. That is the wetland or the planted gravel filter. It's part of the FSTP. And on the left, you can see the settling tank. And behind that, you can see the ABR. And just behind that, you can see the wetland. And to the right, you can see the polishing pond. And below that is the sludge drying bed covered with a shade, so that during rain, you can protect it. Thank you.
Thank you,
Thank you.
very much, Engineer Mopatra. Thank you for showing us a clear, interesting overview of data and technologies used in WSB plants. Now, this is the time of questions and answer. You can write in the chat box your question, and the speakers will try to answer. Maybe waiting for the questions, a participant before asked something about ABR, anaerobic bubble reactor. The question was if it's possible to design ABR for flow of 20,000 liters per day. The answer of Marco was okay. Maybe if Engineer Mopatra, if you can add some data about the specific case of JAT.
Yes, thank you. Yes, thank you. I can give some answer for this. It is possible to design. In fact, in our design of ABR, we have a provision for in the ABR itself, you can settle the sludge. If you remember, before the ABR, the process is the settling thickening tank. Even if you do the settling of sludge in the thickening tank, still there will be some sludge that will come to the ABR. So the first chamber in the ABR is a settling tank again. And that is very helpful. We have seen, because of that settling tank, the chambers, the downstream chambers are not filled with sludge. You need some active biomass for degradation of organic matter in the subsequent chambers. But if you have a settling chamber in the ABR itself, most of the sludge can be settled and it can be removed. And we are able to remove the sludge from the settling tank and also from the settling tank of the ABR by using a cesspool trap. So it is possible, and we have designed it, and we can share the design also. That is not a problem.
Thank you very much. So maybe I have a question for all, but maybe for Marco, about according to you, from your point of view, which is the trend, which will be the trend of low-cost technologies in the future in developing or emerging countries. If you can give us your point of view.
I think it will be increasing because my opinion is that small innovation in this field can bring to very good results. I mean, as also we have seen in this case, this was already like the engineer or the engineering of Jatni plant was already the state of the art. But like in experiences, like in the one of this project, we are seeing that maybe with like I would say minimal, but it's not the correct word, minimal interventions, maybe good results can be found. So in general, I think that low-cost technologies have a very high potential, and also if we consider that there are, for example, if we consider adsorption for removing contaminants, there are many low-cost materials that can be used, and so I think that by increasing the cross-linking of all technologies and solution, very powerful results can be obtained. This is my opinion.
And to answer that, to elaborate further, Mr. Sergio, nowadays we don't call low-cost technology, we call it as appropriate technology. So whatever technology we adopted in Jatni, we call it appropriate because it is appropriate for the local setting. In our STPs, we have adopted, SBR and ASP systems, but we believe for our small towns, it is very costly, and also it takes a lot of time to build a sewer network and STPs, and also we require a lot of high capacity to operate them. So we have limited time, therefore we intended to adopt most appropriate technology for the towns we have, small towns we have. Of course, we call it small because our population in small towns is about 20,000, not 200 or 300. So 20,000 or 50,000, 100,000 we call small towns. And here the sludge production per day is 10,000, 20,000, or sometimes 30,000 liters per day. So in this technology, because it is nature-based, it doesn't require skilled manpower to operate them on daily basis. So there is no frequent breakdowns. And to ensure safety, we have mechanical desludging vehicles. Now also we have imported suction pumps from Italy, and they are already under the trial run. In some houses where the vehicle cannot reach because of the narrow road, so there we are sending these suction pumps to those houses. So those kind of interventions also they are under trial run, will be adopting. And for treatment of that, I consider this WOP is very important for us, because if you look at the 2019 NGT National Green Tribunal order, the standards they are very strict. We can meet the COD or BOD or TSS standard, but to achieve nitrogen and phosphorus standard is too difficult. As Marco has presented, we can attempt recirculation of effluent and also the biochar experiment that you mentioned. So those small interventions from your innovations that we can, once you complete your laboratory studies, and maybe we can go and see how it functions in your laboratory. You can do also some work, maybe one day, half day. And it's quite possible we can adopt those interventions here and find out how we can, from the pilot, from the laboratory to the Jatni plant, how do we transfer this technology and adopt, so we are able to remove nutrients again with the low cost technology or appropriate technology for this setting. and removing also the fecal matters, monitoring them through most appropriate technology instead of using chemicals. How do we achieve the standards? That also we are looking forward to from this partnership, from you mentors on the smart, and of course we will also need the help of water links for coordinating all these activities. Back to you, Sergio.
Okay. Thank you very much. I think the time for question answer is closed. And now there is the last audience polling. Please participate. Give us your feedback.
I think everybody has done the second polling, and the results shows very good ones. And majority are saying, 71% are saying that the webinar has matched their expectation, and the rest is saying that it has even exceeded their expectations. So thank you very much for those who participated in the polling. Thank you.
Okay, thank you, Yolanda. And now, for the closing remarks, I give the floor to my Flora, Executive Director of Water Links. Thank you for your participation.
Thank you very much, Sergio, and thank you to all the speakers, Armando as well, of course, and to all participants. Maybe some of you were just shy. I wanted to really highlight the work that the team has achieved so far in the last year and a half. You will note from the presentations that real things are happening on the ground, and this is the beauty of a sanitation operator partnership under the umbrella, of course, of the Global WOPs Alliance. Because you can see that it's a peer-to-peer learning. It's not a consultant telling somebody what to do. It's really a discussion between peers. So those of you who are in the audience, I see quite a lot of utilities coming from the region. In fact, most of us here now are from Indonesia, the Philippines, and Malaysia. So I invite the utilities to tell us if you are interested in future to be part of a partnership with a utility in future. So do send us an email. Most of you know who we are, and we will consider you. We understand that there's a next round of partnerships coming up. So hopefully some of you may be able to join us. I also wanted to point out that the aspect or the issue of sanitation is really very serious. I think Orisa has done a great job in getting coverage done very, very quickly. I don't think Mr. Mohapatra said when they started, but for those of you who are from the Philippines, I wanted this information stated. They managed to build over 100 plants only the last 8 years. Correct me if I'm wrong, Mr. Mohapatra. You started in 2015.
Yes.
So
Yes. Yes,
So
you're right.
those of us, exactly. So those of us who are trying to start with our first one, please, again, if you need our assistance, OWSSB's assistance, they will be more than happy to help. I'm offering your assistance, Mr. Mohapatra, to our friends here from the Philippines, Indonesia, and across Asia, because really the work that OWSSB has done is just amazing. I haven't seen anything like it. Over 100 treatment plants built, constructed, and operational in under 8 years. And of course, I would like to showcase as well the work that Politecnico and SMAT, as well as Hydroaid, have been doing. You've heard the technical interventions that have been done, but I believe Hydroaid has not managed to explain, but they also have. Sergio, you were too nice. You did not promote the fact that you also developed an online training program for OWSSB, the mentees, which is a programmatic training program with certifications. So again, this is something that for the utilities that are present with us today, you might wish to Google who Hydroaid is, and maybe we'll be able to find occasion to seek the support of Hydroaid in future. Okay, so on that note, I see a lot of messages. Thanking us all. Congratulations to us, to Sergio for an excellent hosting of the session. So I give it back to Sergio to say adios, or how do we say goodbye in Italian? Ciao, I
Maybe-
suppose.
Excuse me, maybe we have a photo?
Oh, our pictures. Okay, yes, I forgot about that. Ladies and gentlemen, can we invite you to turn on your
Yeah, turn on your
videos
video.
so we can take a screenshot
Yeah.
of ourselves, so we can show our friends at the Global WOPs Alliance
Yeah,
that there
That
were
we are
actually
working.
people that attended quite a
that we
number.
are working.
Yes, please show yourselves. Videos on, please. Okay, so up to you. Whoever is taking shot 1 and shot 2, since we can't fit. Okay.
Maybe Tin.
1, 2, 3. Done?
Dan, Tin? Or Pat?
Are we done? Christine or Pat? Taking photo.
One more, ma'am. Done.
Okay.
Okay.
Okay, thank you.
Thank you.
Okay.
Thank you
Thank
all.
you
Thank
very
you
much.
for
Arrivederci.
participating.
Yeah, bye-bye.
To hear
Bye.
from you all.
Thank you.
Bye-bye.
Bye.
Bye.
Bye, Marco.
Bye bye. Thank you.